What's up, math scholars and math haters? This is Mr. W. This is the first in a quick series of videos where I will be going over the practice final exam that I'm instituting for my math classes this semester. Today I'm going to be going over the first page, sections 1 through 4. So let's go ahead and get started. Section 1 deals with finding the ones digit of a multiplication problem. Now the trick with these is that if we want to find the ones digit of the product, we just have to look at the ones digits of the factors and ignore everything else. So whether this is 56 times 73 or 12,356 times 973, all we're doing is looking at the ones digits of our factors to find the ones digit of our product. So 6 times 3, that's what we're going to be multiplying. That's the one particular multiplication that's going to lead us to the answer. 6 times 3 is 18, and the ones digit of 18 is this 8 right here, leading us to an answer of 8. The ones digit of this answer, of this product, whatever anything else is, that ones digit we know is going to be 8. So if we move on to this one, we're focused on 7 times 9. 7 times 9 is 63, giving us an answer of 3. Now for these two, when we deal with square numbers, for instance 99 squared or 54 squared, I'm going to take this ones digit and just worry about 9 squared, or 9 times 9. This gives me 81, and my ones digit is 1. And then for 54 squared, I am just worried about 4 squared, also known as 4 times 4, which gives me 16, which has a ones digit of 6. So again, with this section, the key is focus on the ones digits of your factors so you can find the ones digit of your product. And again, it doesn't matter what anything to the left of these ones digits are. Only the ones digits of my factors will let me find the ones digit of my product. All right, so let's move on to section 2, dealing with integer rules. Now for this section, I'm going to be using a lot of metaphors of money, like borrowing money and paying back money and that kind of thing. But for now, let's start with -3 plus -6. Now the trick, if you learn this in my class, is since we see plus in the middle, we're going to check the signs of the two numbers around it. Since both of them are negative, I'm going to go ahead and do 3 plus 6, which gives me 9. And since both of these were negative, it was -3 plus -6, I'm going to tack a negative sign onto this, and that will be my answer. So this is like if I owed someone $3 and I borrowed another $6. The amount that I owe, I would find by adding my two absolute values, my two just the numbers, and it would still be money I owe. So that would be a total of -9, or -9. Now over here, -7 plus 11. Once again, I see plus, so I'm going to look at the signs of the two numbers surrounding that plus sign, and since now we have different signs, -7 and +11, I'm going to start with a quick subtraction. 11 minus 7. 11 minus 7 is going to give me 4, and now I'm going to look for my bigger absolute value, my bigger number, ignoring signs. 7 or 11, which is bigger? Well, since 11 is bigger and 11 was positive, my answer is just going to be +4. So this is like if I owed someone $7 and I mysteriously somehow found $11. I would have to pay back that 7, leaving me with $4 left over. So over here, we move to subtraction, and this is where it does get a bit tricky, but the first thing to remember with subtraction is that we do not want to subtract integers. We don't like subtracting integers. The first thing we want to do is change subtraction to addition. And the way I'm going to do that is I'm going to take my minus sign in the middle here, and I'm going to change it to a plus, but I also have to flip the sign of whatever number is just to the right of that minus sign. So this becomes plus -5. And now that I see -8 plus -5, I go back to the same trick I used for this problem over here. -8 plus -5, I look at the plus sign in the middle, I look at the two signs of the numbers surrounding it. Since they are both negative, I add 8 plus 5. That gives me 13, and since both my numbers were negative, I tack a negative sign onto that, and I get an answer of -13. Once again, this is like if I owed somebody $8, and then I borrowed 5 more. I would owe them a total of 13. Now over here, we see 7 minus negative 3. And once again, I'm going to use the same trick. I'm going to change minus to plus, and then negative 3 becomes positive 3. So this problem simplifies down to 7 plus 3. Another trick that you might be able to think of is you might have seen all this junk, the 2 negative signs around the parentheses, just becomes a plus sign. Either way, 7 plus 3 gives me an answer of positive 10. So those are the 4 big types of integer rules problems I wanted to put on this practice exam. All right, now section 3, we're dealing with evaluating expressions or functions. And the big idea here is that I get some expression like 3x minus 7, so 3 times whatever number x is, and then I subtract 7 from that, and I get a number to plug in for x. So all I'm going to do is plug that number in for x. 3 times x becomes 3 times 4, which becomes 12, and 12 minus 7 equals 5. So I want us to see that we have 3 times x represented, just I plugged in 4 for x, and then we still have the minus 7 represented. We're still doing every part of this expression. We're still considering every part of that expression, but we just went ahead and plugged in the number it gave us for the variable. So if we come over here to evaluate 7 minus 2x when x equals negative 1, I'm going to start, once again, by taking negative 1 and plugging it in for x. So this becomes 2 times negative 1, and this is a rule of multiplying integers. If we have a positive integer times a negative integer, it becomes a negative integer, so this becomes 7 minus negative 2. Once again, I can use that trick of 2 negatives becoming a positive to give me 7 plus 2, giving me an answer of 9. Now these next 2 down here are the exact same idea. They just look a little bit different because they use what's called function notation. We have a function, f of x, equals 5x minus 9, and we're supposed to find f of 3. So this is the exact same idea. I'm going to take 3, plug it in for x. 5x becomes 5 times 3, becomes 15. Subtract 9 from that, and we get 6. Once again, we see 5x rewritten as 5 times 3. I brought down my minus 9, and we went from 5x minus 9 to 15 minus 9, which gave us 6. And over here, I made a little typo in this one. I called the function g of x, and I said find f of 4, so I'll go ahead and correct that here. Anyway, I take my 4 that it gave me for x. So I plug it in, and this becomes negative 2 times positive 4, which gives me negative 8. I subtract 5 from that, and it's like I'm adding negative 5 because of that subtraction trick. We never want to subtract, we just want to add. So this gives me negative 8 plus negative 5, which, if we remember from a previous problem, actually gave me an answer of negative 13. So those were all the problems that dealt with evaluating expressions and evaluating functions. Once again, the big idea is we want to take the number that we got for x, just plug it in. 3x becomes 3 times x, so 3 times 4. 2x becomes 2 times negative 1. 5x became 5 times 3. Negative 2x became negative 2 times 4. And then whatever addition or subtraction piece or whatever else was left at the end, like minus 7 or 7 minus 2x, we had to put the 7 minus there, or minus 9 or minus 5. Whatever that piece was, we had to bring it back. So finally, we're going to deal with circles. And based on the information we're given, we're supposed to write the expression for each circle's area and circumference. So let's quickly go over what area and circumference are again. We can find the area of a circle by multiplying pi times the radius squared. We can find the circumference by multiplying pi times whatever double that radius is, or by the diameter. we'll actually end up using both of those here. So if we come over to this circle, we have, this time it gives us the radius of 4, which means that if we are looking at pi r squared, instead of pi times r squared, it'll be pi times 4 squared. 4 squared, also known as 4 times 4, is 16. So if you're doing this without a calculator, which my students will be, the expression that would represent this area is 16 times pi. And to come over here, if we're looking at for the area of this circle, well, this time it's a bit trickier because it gives us 12, and that's our diameter. So the diameter goes all the way across, but the radius just goes halfway across. So the radius is going to be whatever the diameter is divided by 2. 12 divided by 2 is 6, and that's going to be my radius. So my area would be, instead of pi r squared, it would be pi times 6 squared, which would give me 36 times pi. Now again, for my students, I'm not expecting any of you to find this without a calculator. Just find the expression, just find the number that we would plug in, or that we would multiply by pi. So now let's move on to circumference. Circumference is where I take pi and I multiply it by whatever double the radius is, or just by the diameter. So down here, it's very easy. My circumference, the diameter is already given, so that's going to be 12 times pi. Over here, if my radius is 4, that's going to be pi times 2 times 4. 2 times 4 is 8, meaning that my circumference could be represented by 8 pi. So again, this kind of builds off that whole evaluating expressions piece, because what we're doing here is we're taking a number that the problem gave us for radius or diameter, and we're plugging it into each appropriate expression in order to get something out of it. In order to get something out of it that represents area or circumference.